Right, so we're going to be doing an inference test, and first we need to decide what type of test we are going to be doing. We're going to read through this problem and keep in mind, is this a confidence interval or a hypothesis test? And is it one sample or two samples? In a random sample of 1,250 drivers, 450 said they would cut their driving time by 10% if it helped the environment. Find a 95% confidence interval estimate of the proportion of all drivers who are willing to cut their driving time by 10%. So we see in the problem here, they want us to construct a 95% confidence interval. So that means we are going to be on the confidence interval side of our flowchart here on the left. And then one sample or two sample is our other question. It says in a random sample of 1,250 drivers, that is the only sample that is mentioned here, so there is one sample. This number 450 is not a separate sample. That's the number of successes from our original sample. So do not let that confuse you. There was only one sample that was taken. So we are doing a confidence interval for one sample. We are only working on proportions on this test, and that is a 1 prop z interval. We could also tell that it is proportions because it uses the word proportion right here. So even if it wasn't for this test and you didn't know for sure it was proportions, this would clue you in that we are working with proportions. So let's actually run that test. You can find this template in the study guide or in the Desmos. It is called a confidence interval for one proportion. Box 1, we're going to name that test. We just figured out that name. It's a 1 prop z int. That's what we found here. Confidence interval, one sample, proportion, 1 prop z int. Then in that box, we are also going to name our p hat. That's going to be the number of successes divided by the sample size. That'll give us our p hat every time. Just to write that down for you here. P hat is the number of successes over the sample size. So our number of successes here, we're going to define success as if someone would cut their driving time by 10%. Here there are 450 people that said they would do that. So 450 will be in our numerator. The total sample size is 1,250 here, 1,250 in our sample size. So 450 divided by 0.36 is going to be our p hat. And then I'm going to give some context for what is the p hat in this problem. It is the proportion of adult drivers who would reduce their driving time by 10% if it helped the environment. And I get that from the problem. That is just what is being described here. They said they would cut their driving time by 10%. That's my box 1. So that is all for box 1, and then we are going to check the conditions in box 2. The first condition is the random condition. I will look in the problem and see if random sampling is given. It is. It says random sample. So I will write random sample is given. Number 2 is the 10% condition. The goal of that is for our sample size to be less than 10% of our population size. We're going to use that sentence template. It is reasonable to assume that the first blank is filled in with our sample size. Our sample here is 1,250. So it's reasonable to assume that that 1,250 is less than 10% of the population of, and then we're going to describe what the population is. Here we can see in this problem, it is those drivers that said they would cut that driving time by 10%. Oh, not sorry, that was wrong. The whole population is not the ones that said yes to this. It is all the drivers. The whole population is all the drivers. The ones that said yes about the 10%, that was the people that were successful. Those were our number of successes. The whole population that we got the sample from is just drivers. So that's what we would fill in here. And then we would say, therefore, independence can be assumed. There's conditions 1 and 2 checked. Condition number 3, we need to make sure that our sample size n times p hat is greater than or equal to 10, and our n times 1 minus p hat also has to be greater than or equal to 10. Our n was 1,250. Our p hat was 0.36. I'm going to plug those in here. So n 1,250 times 0.36 has to be greater than or equal to 10 for this condition to be satisfied. It is. It comes out to 450, and that is for sure greater than or equal to 10. I'm going to do the same thing over here, plug into this one. So 1,250 times 1 minus 0.36 is also greater than or equal to 10. 800, that is also greater than 10, so we're good there. And we can say, therefore, the large counts condition is satisfied. Okay. That's all my conditions in box 2. Box 3 is going to be that calculator talk. We are doing a 1 prop z int, and then we're going to tell the AP graders what we put in our calculator to actually construct that confidence interval. It's going to ask you for x, n, and C level, confidence level. Our X is the number of successes here. A success is defined as someone that said yes to cutting that driving time. We actually already used that number over here to calculate our P hat. That's 450. Our sample size we used as well, that's 1250. So you can see that our P hat calculation, that number of successes over the sample size, is actually X over N. Those are the same numbers we put in our calculator. Confidence level for this problem, we are at a 95% confidence level because they want us to construct a 95% confidence interval. So for C level, I'm going to write that as a decimal, 0.95. When I put this in my calculator, it will get me the confidence interval out, and I will tell them that in box 3 as well. So my X is 450, my sample was 1,250, my confidence level was 0.95, and that confidence interval comes out to be from 0.333 to 0.387. It also calculates your p hat here for you. So if you want to do box 3 first, use that to calculate your p hat and then fill that in box 1. Feel free to do it that way. Just make sure you're still checking those conditions. So that's everything for box 3. And then box 4, we're going to interpret that confidence interval. There is a template for that where we'll just fill in the blanks. We are blank percent confident. That blank is going to be filled in by the confidence level here. We are 95% confident that the true proportion of, and here we'll give context for what that thing we're looking at is. We were looking at the adults that said they would, or the drivers that said they would reduce that driving time by 10%. So we are 95% confident that the true proportion of drivers who would reduce their driving time by 10% if it helps the environment. Give that context. Environment. I spelled that wrong. Whoops. And then we're going to end this by saying our confidence interval is between these blanks here, blank and blank you see on that template, is where we fill in the numbers for the confidence interval. So between 0.333 and 0.387. So again, that first blank we filled in with the confidence level. Second blank we filled in with the, I can't stand that the N's not in there. Second blank we filled in with the context. So the drivers who had reduced their driving time. The other blanks here, these last two, these are just both the numbers that I got in my confidence interval in part 3. And that is everything you would need to do on this FRQ question for a confidence interval for one proportion.